Farmers gathered recently at 5 points in Fresno County and at UC Davis to learn more about the practice of conservation tillage. Conservation tillage is a farming system that seeks to reduce the number of passes a tractor makes over a field in order to prepare the soil for crops. The benefits to the farmer can include a reduction in fuel costs, improvement in soil quality, reduced soil erosion, in addition to saving time and reducing labor cost. The University of California organized the all-day conferences, which featured demonstrations by equipment suppliers and presentations by UC researchers. Farmers who are experimenting with conservation tillage also shared their initial results with other growers at the conference.
I'm going to go through some of our experiences real quick here. There isn't that much to say, but I would like some questions. I would like some discussion. I'm hoping I learned something from some of the other farmers in the room today also. I'll start off with what we've done on our ranch with the no-till wheat. We did a little bit 2 years ago, and then last year we planted about half of our wheat with a no-till with a couple of different drills. And we figured just in that part of the operation, we saved about $50 just in groundwork right off the bat, not preparing the ground in front of the drills. We have harvested most of it this year. We're not quite done. We don't have our yields exactly. Counting trucks out in the field, it looks like the yields are very similar. Our first no-till field went 6,000 pounds, and we've been between 5,000 and 6,000 on the rest of them, except for one that had some frost damage, the earliest one we planted. So we're pretty happy with that. And just looking at the wheat out in the field, comparing the no-till and conventional, the no-till fields have had better color, and there is a chance that we will get by with fewer top dressings of fertilizer with the no-till. It seems that not putting that residue in the ground maybe is not tying up as much nitrogen, and we're getting a better response from the fertilizers we do have down there. We've used, this year, most of it was done with the John Deere 750 drill, and we've been real happy with that. That did a nice job for us. We've tried over the years when we used to do dry land grain, Hay Busters, Palouse, Cross Slots, Great Plains is also one that we use somewhat this year. But we're going to continue that. We're going to plant more of our wheat this next year with that. And of course, there's the obvious advantages that Max and everybody else has talked about with the erosion. You get those first few fall rains around here before your wheat's established, and you can get a lot of runoff. And we don't have all that destruction in our soil with all that so-called recreational tillage that everybody used to do. And one of the other things that we've all learned about in the last couple of years that's a great benefit is we are building up some carbon in our soils. We're not losing it from the respiration process when that stuff is burned when you turn it over, and we are adding all that residue to the soil. The other thing we did this year was we did plant some corn, not a lot of it, in a no-till situation. We used the John Deere MaxEmerge, and that did a very good job for us. Right now, looking at the corn and how it's growing compared to the conventional, we're quite happy with it. It's all growing about just as vigorously, has very good color. We have good stands out there, so we're trying to see, look at this very realistically and trying to think why we shouldn't be doing this more. Except for the fact that you just shouldn't be growing corn unless you have to around here. It looks like to us anyway that we should do it with the no-till drill. One of the problems we have had with corn in the no-till system is the corn residue in the next crop. We followed some corn with no-till wheat this year. And I know John Bradley said he likes to leave all those stalks standing up, but when we baled the wheat straw, it had corn stalks in it, and one of the buyers looked at it and said he didn't want it. So that's something to think about. We also had that experience with some oat hay that we planted into, no-till planted into some corn stubble. We had some corn stalks in the oat hay, which reduced the price a little bit. So that's something we're looking at. We will probably try and roll down our corn stalks this fall, and then we're going to have to pay a lot more attention to the direction that we do run the drill, because he's right, you need to plant in the same direction that corn stalks are leaning that the harvester went, because you will have fewer problems, because we did have some problems with that John Deere 750 no-till wheat drill in the corn if you tried to go the opposite direction the harvester went. So there's little things like that that we're all going to learn after we've done this for a while. Another thing I tried just this year for the first time was using a cover crop in front of my tomatoes. And I'm not really calling this no-till, but we did put a green manure crop, cover crop in front of some tomatoes with the intention of leaving quite a bit of that residue on the surface and growing the tomatoes, transplanting into that. We planted some legumes primarily, but there was volunteer grains also in this crop. And the volunteer grains are the problem. There's a lot of straw there, and that was hard to work in. I guess I just wasn't brave enough to try and leave all this on the surface through the season and then try and harvest the tomatoes, where you have to go, as everybody knows, goes a couple inches underground and bring all that residue up on your harvester with your crop. So I did some light tillage in the spring. After I sprayed it with Roundup, the cover crop, chopped it, did some light tillage with a bed disc, and also with a chisel, ran a chisel shank with a coulter in front of down the center of the bed, we transplanted into it. Unfortunately, it was done in May when we had the winds and the hot weather around here, and you can see around the county there's a lot of spotty stands from that weather, and we did lose a few of the plants. But when we tried to cultivate and put on fertilizer, and when we tried to run our incorporator to lay by some herbicide, we had a lot of problems with the residue. And so that was a tough situation there. I thought I needed the herbicide. I didn't want to rely on that residue just for my weed control. I have some ideas on how I'll do it a little bit different next year. We did those things though and got past that, and then we went to irrigate, and we did have quite a few problems with the straw, damming the furrows. We had tremendous infiltration. The water just really went into the bed. So if you're on ground that's real steep and has a hard time getting the water into the beds, the residue is a really big help. And even the second irrigation, which we're in right now, we're getting very good infiltration. We've had to spend more labor out there just with irrigators trying to keep those dams from building up and the water breaking clear over a 60-inch bed. So we'll probably end up doing an extra tractor pass through those fields to clean those dams out after irrigation. But the vines look really good right now. I'm very happy with how vigorous they look, and the blossoms that are on there are really blooming, full bloom right now. But I need to think about a few changes, and a couple of my ideas. When I do have a volunteer wheat situation and I don't want all that grass, I may use a light rate of Roundup in about February. I think a very light rate, in my experience, doesn't do much to the legumes, and they'll keep growing, and it will stop the grasses, so I won't have as much problem. I think chopping your residue into smaller pieces will help too, because it's the long straw that causes the problem when you go through cultivating. And we were cultivating with discs, coulter discs in front of all the knives and everything, but still there were some problems. And I may keep the cover crop away from the center of the bed, so I'll have a cleaner slot right there to transplant into. Although the transplanting was not real difficult in the residue. That's something that certainly can be done. But mostly it comes down to the tillage equipment I have. I need to refine that a little bit and see if I can get some tillage equipment that'll work a little bit better with the residue in a tomato situation. But that, I think, is a challenge for all of us in this county to see how we can figure that out so we can do some maybe no-till, at least conservation till tomatoes.
We're into our second year of no-till with both wheat and corn, and we started into no-till with no esoteric reasons at all. We got into no-till in an attempt to lower our costs. We wanted to make fewer trips across the field. We have less labor, less fuel, lower input costs, and we started out last year with a John Deere planter. It was 15 feet. We jumped to a 40-foot planter this year. That's made some additional challenges, but it's also this business of making almost one pass where you're making 3 for at least planting, and you're knocking out everything else. The equipment is available. The technology is proven in millions of acres in the Midwest, and the adaptation of the technology to our non-summer rainfall areas has presented some challenges. I did enjoy Mr. Carter's comments about one of these max merge planters that he thought you could plant it in this concrete floor, and if it rained, it would come up. And that's kind of my impression of those planters. They're just, they'll get the seed in the ground. It doesn't make any difference what's on top of the surface. They'll get the seed in the ground. We started out with, again, a planter that was equipped for eastern summer rainfall areas. We had some starter fertilizer placement problems where the starter fertilizer was not being placed deep enough, and we had to go back and do some remediation on that. And we then had to make some modifications of eastern equipment for side dressing. The issue of these furrows being blocked with residue dams for irrigation is something that can be an issue. Field we dealt with last year was that had some of the biggest issues was corn following corn. So it can be done. It is manageable, and I think it may be just another pass of chopping or using these waffle coulters. I think that's the term they use. And I think the other joker that we injected in the deck this year is when we shifted from 15 feet to 40 feet, you end up with this real wide planter, and your listing needs to be very precise. I think you're getting into GPS listing for the most part. The positive part of all of this is the system works. Weed control is achievable and economic, and I think that's probably the big key to it. I think we're saving in irrigation in this no-till. The combination of not working the ground and having the carryover moisture from winter, coupled with this residue on the soil surface. We're reducing the weed seed bank that's in the soil, and I think that's maybe one of the most significant things in this whole culture. I don't know what it's going to be like down the road in 2 or 3 years, but last year, into this corn field, we had a situation to where the previous year's corn was just crawling with nutsedge, and we had incorporated lasso, and lasso slowed it down, but we had to go back in and we made a treatment with permit, and the permit did just a bang-up job on this stuff. Well, I had the mentality when we came into it last year that we better be ready. We get to this stage of the game and the field is going to go green again with sedge, and it did not. There was a little bit of sedge in there. The Roundup took it out, so we didn't bring the new weed seeds to the surface. So some of the issues on weeds may be somewhat self-correcting. We're improving soil tilth, water penetration. Bruce talked about this. I think that is something that we're doing. The future and the challenges. I think one of the things that's going to make GMO or make no-till and reduce tillage a lot better is going to be GMOs. And there's going to be political pressure against GMO off into the future, but I think that's what's going to help make it go. In the corn situation, California varieties need to catch up with the rest of the Midwest in terms of where Roundup Ready is introduced. If the best varieties and people's seed lines were Roundup Ready, that would make this thing go a lot faster. We need to integrate our no-till into a broad program of crop rotation, and this is the ability to take a cornfield and roll it into something, well, corn to wheat to maybe tomatoes, and then back through that cycle again. We need to continue to adapt machinery and implements to our own conditions. There's going to be a volunteer problem if everything is Roundup Ready, and Roundup Ready volunteers could be a big weed problem out in the future. I don't know. And I guess I would say that no-till is a process of adaptation and learning. Everybody's going to adapt to their own conditions, and not any one dogma is going to fit everybody's conditions. Thank you.
I appreciate the chance very much to come up here. We certainly, the cotton industry is one that has a lot of concerns, like in many other commodities right now, with problems with very poor economic returns, high input costs, very, very poor, almost record low, essentially, commodity prices right now that are really putting the squeeze on growers. So this is just one possible alternative from the show of people that Jeff had at the meeting down at the Westside Field Station on Tuesday of this week. I think we have many, many cotton growers who are interested in any available alternative they can come up with, especially if it's related to reduced input costs. What I'm going to talk about is a piece of equipment called a Pegasus. This was some study that basically we decided to take this out onto some grower fields after quite a few years of research had been done largely by the USDA ARS unit at the Shafter Station. I want to mention a few names. My name is Bob Hutmacher. I'm located down at the Shafter Station. The farm advisor Ron Vargas was involved at the Madera County location. We have UC staff at both of these locations that were very involved. Lau Carter, Joe Chess, and Vic Penner from the USDA group at Shafter. Some cooperation certainly from Monsanto Corporation, John Bradley, Henry Wu, Mike Hansen, Barbara Kuchner, and the most important people on these, since these were on farm trials, Newhall Farms up in Madera County, Roy Catania, and Way Farms down in Kern County, Rick Wegas and Mike Young. They were really all important in making this work. Basically, well, I'll just mention, I apologize for not having a picture of the Pegasus unit itself. Basically what it is it's designed as a one-pass system. It's a high horsepower requirement type of unit, but it's a one-pass system that's basically designed to undercut the cotton stalks at harvest time or after harvest time, basically fold them all in so that the stalks go down into what looks like a rope of cotton stalks that gets basically shoved down with a stuffer wheel down into a slot in the ground, and then when you're done you have what essentially looks like a listed bed in preparation for going into the fall. Again, I'll mention right off the bat it's a high horsepower requirement, 200 horsepower plus for the size units that we were using on these farms. Another thing that I'll try to mention a little bit about, it's real important when you're talking about this use of any kind of alternative tillage system in the San Joaquin Valley with cotton. We have what's called the pink bollworm program, management program from the California Cotton Pest Control Board. Basically, it's about a 35-year-old program that's for biological control of pink bollworm. It requires a host-free period, and it requires basically plow down complete coverage of the stalks. So you can't have stubble cotton or these type of things under the system, the current regulations in California. What we were looking at then also was paratill versus no paratill comparisons. It's a paratill is a bent leg shank, basically for ripping essentially underneath the listed bed that we end up with, and we tried that for comparison. Particularly there was interest in some of the heavier ground where we tried this. Three comparisons, basic comparisons in terms of tillage. Again, this is just with this Pegasus type of system. Was limited tillage, which basically was just all the bed prep work with Pegasus, furrowing out for irrigation because it's all furrow irrigated ground, and then no additional cultivation for weeds. What we're calling conservation tillage, the same basic prep with a Pegasus, furrowing for irrigation, but only 1 to 2 cultivations, excuse me, a mistake there, 1 to 2 within season irrigations, 1 to 2 within season cultivations under that system, and then conventional, a more conventional type of setup, standard bed prep, a lot of passes in that field, and then within season cultivations as well. Again, I won't talk really about these results, but we had herbicide treatment comparisons within this system as well. The reason for that was that the initial interest in this, certainly with the growers that we had as cooperators, was use of transgenic Roundup Ready varieties at both of the sites I'm going to talk about. This system could be also evaluated under alternative transgenic systems such as the Buctal-resistant varieties we now have available. It also has been tested in some smaller scale studies we've done, and the USDA group has done on conventional cotton varieties. I'm just going to mention, I'm not going to try to put too many data slides up to try to keep this fairly brief, but I'll mention some areas of concern and evaluation that we have, and then just give you a real capsulized version of what we think the summary is. One of the things we're certainly interested in was efficacy of how well this system worked in burying the stalks and the residue. We had some very large cotton, some 4 foot tall plus cotton in excess of 3.5 bale yields in some of these fields, particularly at the Kern County location. And the system worked very well. We really did put it to the test at those 2 research site locations because particularly in 2000 we had very, very dry soil conditions, and we're working with a blocky clay loam soil, and it really was a challenge to be able to pull that system through there. Now, to be fair, I'll also mention that this system was tried on a broader range of additional sites where we didn't have full-blown comparisons, but clay loam soils where we had higher moisture content could really be a problem with this type of system, and we bogged these systems down, had some significant problems. So if you were trying to use this system and you got caught by a significant amount of fall rains or had wet fields to begin with, there would definitely be some problems with it. One thing we're also interested in on the second part there is whether or not we needed additional touch-up treatments, basically additional cultivation or tillage practices in order to have beds that would comply with the pink bollworm regulations and pass the ag commissioners. And I'll just mention, I don't want to get on a soapbox here, there was a lot of variability in ag commissioners' responses in terms of what passed, what didn't pass. We had very good luck with the Kern County, Madera County, Kings County ag commissioners. There were some other interpretations that definitely had some impact at the other sites. One other additional area, salinity management, was something we were concerned about, particularly in the Kern County site. There is a significant amount of salts present. When we go to a permanent bed system, whether it's the Pegasus units or anything else, we're somewhat concerned as to, in an area with 4 or 5 inch annual rainfall, whether we're going to be able to get adequate leaching, adequate downward movement of salts rather than concentrating them within the bed. So we didn't have problems within the confines of the 2 years of the study, but it's something that we certainly could see some trends that we'd either have to deal with rotating out to a different type of cultivation or moving in sprinklers or something. One thing I wanted to mention just real quickly here is certainly when you bury something like this stalk underneath the bed and then you're going to push the beds down and plant over it, it matters a lot, particularly in a crop like cotton where we try to plant to moisture. You're going to be shoving that listed bed down and then trying to get the seed planted down to moisture. And we did have some concerns about where the rope would actually be located. We did have some stand problems in a few parts of the field, and those tended to be concentrated more toward the area where the buried rope of stalks would be shoved one way or another, maybe a bobble in how the equipment operated, and you'd end up with that row of stalks shallower than you desired and maybe more toward the bed center. The way the equipment's designed, it's supposed to end up about 4 to 6 inches off the bed center. So again, it wasn't a major problem in our couple years of experience with it, but it certainly is something to watch. One area where we had some concerns but didn't really see any problems, at least within the confines of the studies at the Shafter station over 4 or 5 years, or the ones on these 2 grower sites, was whether or not we would be concentrating the plant matter and inoculum potentially right in that bed center and see some worse problems with verticillium. We planted some less vert-resistant varieties just as sort of a test plot within the fields and did not see any problems, even though there was a significant amount of vert in some of these fields in the year 2000. So again, the answer may not be clear on that one yet. We didn't see problems with that. We had some concerns with whether or not we would have moisture retention problems, how the root system would develop if we ended up planting in some areas almost right over that stalk. And just the brief version is that we did not experience stand problems in either the sandy loam or the clay loam site. due to the residues. And again, one of the growers insists on using chicken manure applications, ground applications on their field. We didn't see any problems with nitrogen availability. Both of these fields had fairly high nitrogen status during the course of the experiment. So again, something to keep in mind, but we didn't see problems. One thing I would like to mention a little bit about is, I think not just with this Pegasus system, but in some of our soils in the San Joaquin Valley at least, any of these changes which result in major reductions in the number of cultivations in the field, we have quite a few soils that the infiltration rates change quite a bit during the course of the season. And particularly if you eliminate some of the within row or within furrow cultivations, we did see some impacts there. This is just maybe a quick way, a little bit hard to look at this, but this is relative water run times, and as you go from the no-till to the conservation till to the conventional till, the three different colors are just 340 feet into the field, measurements made at 680 feet into the field. The purple is the 1,020 feet into a quarter-mile run field. And basically what this data showed in looking at relative water run times is that data here is for the third irrigation of the season. We're seeing significant reductions in water penetration in the conservation till and the no-till plots compared to conventional. And this would mean that the growers would have to seriously consider changing durations of run, do more frequent irrigations to get on the same amount of water to match ET, or consider something like a tailwater recovery system. I'll just wrap up with a couple comments about yield responses. It's certainly something our growers are concerned or interested about. At the Madera site, again, a sandy loam soil in the north part of the San Joaquin Valley, we had about a 15% yield improvement, a little in 1999, about an 8% yield improvement in the year 2000 of the Pegasus. All of the Pegasus treatments averaged over conventional. Some of the measurements we made indicated that perhaps we were getting better rooting depth and better water penetration in that particular soil. We don't have a real clear consensus as to what was going on. We did see some differences at the Kern County site, and in the interest of time, I'll just go ahead and summarize them here quickly. We saw in the Pegasus treatments, averaged across all of them, we saw 1 year about a 4% lower yields compared to conventional, and the second year about 11% lower than conventional. And part of what we did in this particular field, we had yield monitors and did some remote sensing work as well, a lot of soil salinity measurements, and we feel pretty strongly that we want to be fair about what the impacts are, but there are some soil salinity issues in this particular field that certainly were part of what was going on in terms of the yield differences. So in general, most of the past research has said that you don't expect much of a difference in terms of yield responses if you average it out across these. That's more or less our experience. In terms of cost of production impacts, certainly the thing the growers are most interested in our area is reductions in number of cultivations, the number of times they have to open ditches for irrigation passes. There are some increases if you're basing this system on the use of transgenic cottonseed, which we used in both parts for this comparison. We were seeing average numbers of about $40 to $75 per acres in reduced cost with the Pegasus system combined with reductions in tillage, and that's really where the savings and costs came from. That'll certainly depend on local soil conditions and all. One thing I need to make very clear in use of this system, it's a $40,000+ system. It requires an auto guidance system on the hitch to operate and keep working well. One thing that I think is a significant problem, at least with this piece of equipment, is it really requires some skill with equipment settings and making infield modifications according to the soil conditions. So this is not something to put your least experienced person or somebody like me on in order to make it work out in the field. It really required among the best equipment operators on the farms to make it work. Particularly under the more challenging soil conditions. Work real easy in the sandy loam soils, no problem. The clay loam soils, if they're too wet or too dry, it requires much more work and adjustments.
I'd like to begin by acknowledging all my collaborators, including Jeff Mitchell and Scott Park, who's been involved from the ground level in designing this trial. And I want to acknowledge Nick Madden, who's really the lead on this project. He's a graduate student here at UC Davis, and Enrique Herrero, who works with me in Sutter County. Well, there's been a lot of interest in utilizing cover crops in the Sacramento Valley in the last few years. And for example, Gene Meow, who's a Yolo County Farm Advisor, and Paul Robbins from NRCS have done trials with cover crops as for the winter production, followed by a tomato crop, and have found many benefits as far as infiltration of rainwater during the winter, and also boosts in yields in conventional processing tomatoes. For organic production, as you are hearing from Bruce Rominger, it's very important to have a nitrogen boost and improve your long-term sustainability and fertility of your soil. So cover crops are certainly very important for vegetable systems. But as we have heard today, the challenge is always to try to incorporate these cover crops into your soil so you have a nice clean system like here, and you don't have trash in your field. And this is Scott Park, who you've heard speak earlier today, and he is he's been using cover crops for his organic tomatoes for quite a few years, and has understood the headaches of incorporating them before planting tomatoes, transplanting tomatoes. And his interest in this project was to look at some of this conservation tillage equipment or high residue equipment and see if we could make use of it to sort of open the bottleneck of using the cover crops for tomato production, to give some options so you wouldn't have to necessarily incorporate the cover crop all at once before planting. Perhaps we could cut down the cover crop, use it as a mulch temporarily, plant right into it by transplanting with a no-till transplanter, and then later do our tillage as we get weeds. So sort of a delayed incorporation type of treatment. And it had a lot of questions about how good of a weed control system this would be. Would we be giving up some of the end benefits of not incorporating the crop? So that was really the reasoning behind running this trial. And so what we want to do is design a trial that would look at sort of all the different options with tillage with these cover crops, so we could see how we could optimize nitrogen, weed control, also be able to irrigate in this system, and improve the long-term soil quality, or increase the organic matter, the long-term fertility of these soils, and ultimately, of course, optimize yield and fruit quality. And remember, these are organic tomatoes. We don't have the option of using herbicides, so we want to be sure that our cover crop doesn't grow back once we kill it if we leave it on as a mulch. This slide just shows the treatments that we're using, and we want to look at a cover crop that would provide a good nitrogen boost, and that would be our legume mixture, and also a cover crop that might provide a better weed control mulch, and that would be a grain legume mixture. And then impose different types of incorporation treatments on these different cover crops. And the standard one would be just incorporate it before doing our transplanting. That's what is generally done. Or, as Scott was interested in doing, was turn it into a mulch and use the no-till transplanter to plant into it, and then we'd slowly incorporate it as we got too much weed pressure in the field. And then we went to a little more extreme. We made a mulch and just left it no-till the whole season, or did strip till. And then we compared this with a fallow treatment without any cover crop using the conventional tillage. So I'm going to just briefly, hopefully, go through the results from our first season and show you what's been going on in this current season. Here you see the Buffalo stalk roller taking down the cover crop, and it worked pretty nice. And here's the ripper stripper we used for the strip till treatment. And the interesting thing was, as you see here, it's being used in the legume cover crop, which wasn't one of our treatments. When Scott started playing around with this, when Jeff brought it up, before I even got out in the field, they had done, I guess, half the field outside of the trial. So he really liked this implement. Now, when we grew these cover crops in the first season in 2000, as you see, the soil profile is filling up with moisture as we get rain in the winter time, but the rains cut off pretty early, and the cover crops started pulling out the water in the soil profile, as well as the weeds in the fallow plots. But we even had more water loss in the cover crop plots. And we probably waited a bit too long before taking down the cover crops. And this made doing the transplanting quite difficult. Now this is the results of the residue cover from the different mulches through the season, and we definitely saw that using the grain legumes mixture, we got a much better residue mulch on the surface, where the legume mixture broke down quite readily and really didn't provide a lot of cover for weed control. This slide just shows you that when we look at the weed control, it wasn't really a function of the cover of the mulch, but more the tillage treatments. We had a very poor weed control where we had our no-till treatments or our strip till. There was a point where we had to come in and do some cultivation if we were going to optimize our weed control. So going to that extreme no-till treatment certainly isn't adequate for growing these tomatoes. And one sort of surprise we didn't realize, we had inadvertently planted some rye grass in our mixture, not rye grain. And the regrowth was really a problem throughout the season. And it seemed that the competition of this rye grass really stunted the tomatoes. And when we looked at the soil nitrogen, the mineralized nitrogen, you could see that the legume cover crop, which is in those green symbols, was providing some boost of nitrogen over the fallow plots, while the grain legume mixture seemed to be tying up the nitrogen. Now, I'm not sure if that's causing the delay of growth in the tomato crops, or other factors due to the ryegrass, or just the drier conditions that we had in those no-till treatments. But when you looked at the yield data here, we had some train wrecks, and other treatments worked out okay. The legume conventional and then just the fallow conventional obviously gave us our highest yields. These are pretty good yields for organic tomatoes. Any of the treatments that had that grain legume, even if it was incorporated into the soil before transplanting, and we didn't have any regrowth, we had lower yields. So in this season, we had a lot of problems using that cover crop mixture. Now I want to show you what's going on with this current season. We made sure we didn't have any rye grass in there, but we did have rye grain in there, our grain legume mixture this season. And you see we had lots of biomass This is the grain legume mixture. And again, we're using the Buffalo stalk roller to take it down. Now here's the conventional tillage, and we didn't have any cover crop, and you see how that looks. And in comparison, here's the conventional tillage, and here's the grain legume mixture. So the grain legume did not inhibit the growth of tomatoes this year. And then here's where we first put the mulch on, and then use the no-till planter to plant our tomato crop, and then later incorporated that grain legume cover crop. And you can see there's more residue on the surface here. And this is our no-till treatment, and it's still growing, maybe not as much growth as we were getting with our delayed incorporation, and you have even more residue on the surface. Here's the no-till legume mixture, and you can see the residue is already broken down. And this is the strip-till grain legume mixture. Still have quite a bit of residue. It's a little bit more weedy, but in every case, it looks like everything's doing much better than the first year, and perhaps we've learned how to do this better. Now, one unexpected part of this is we did have some increase in biological activity, and it seemed to be these gophers. At first it seemed like an interesting curiosity, but when we started seeing half of our plots disappearing, I was wondering perhaps this continuous no-till system is going to be more difficult than we thought in controlling gophers. So just to summarize our preliminary findings, looks like the weed control benefits of cover crops, mulches, are quite marginal. Some type of cultivation is going to be required to use them. And the legume mixture seemed to improve the nitrogen supply of the tomato crop, while the grain legume mixture may be tying up the nitrogen. We have some evidence in the first year of that. And, well, of course, the yields were also highest in the legume conventional tillage treatment and the conventional one. But it does seem like this delayed incorporation made possible with conservation tillage equipment might improve the flexibility of using these cover crops in these organic vegetable systems. And I'll have the results for the next year, or for this year next year. Thank you.
Okay, what I'd like to do is end up, as I say, with a sort of a summary of some of our research over the last several years. Well, certainly something that has been mentioned, and this is documented here, one of the incentives or motivations is going to be the high cost of production. And that you can see here with the rising diesel costs, and believe me, in my own interactions and questionnaires and surveys with folks, this is one of the major driving factors in this whole thing. Now, something we didn't talk about too much in today's conference, but also is a driver for a number of growers, is soil quality preservation, soil quality improvement. And one of the ways to looking at that is how much tillage is really necessary, because recent research by USDA in the Midwest has shown that the act of tillage is aerating, is causing a lot of carbon dioxide to be emitted to the atmosphere, and as we know, carbon dioxide is a greenhouse gas, so there are those kinds of issues as well. Can a reduction in tillage contribute to a reduction in carbon dioxide losses? So those are some of the underlying motivations that are afoot, I think, in driving this interest here. Now, as Michael talked about our early research with processing tomatoes, we would pull up off-season fall beds that were shaped. We'd grow an off-season cover crop, kill it in the spring, transplant directly into that surface mulch, and then, as Michael pointed out as well, we recognize you're not going to get complete weed shading with that mulch alone, so we've developed the ability to in-season cultivate. And all of this is designed on the principle of trying to keep dedicated zone traffic production lanes throughout a field. So I'm going to share some of our early work here. Looks kind of hairy, but this is a winter cover crop, probably planted in October, mowed down with a sickle mower in early March there. And we've tried a variety of different mowers. A flail mower butchers the cover crop much more aggressively and leaves a much different texture here. Again, recognizing the difficulty of surface mulches alone to shade out weeds, we've used a high residue cultivator that you saw out today. It's been adapted for a 3-row configuration. This is an on-farm study down in Tracy. This particular cover crop, it worked very well. It was a light cover crop. It was a predominantly vetch cover crop. But as Michael, I think, might have said, it's not going that smoothly through all kinds of cover crop mixtures. One of the things our early work with Enrique Guerrero, his master's thesis was down at 5 Points, and he followed 2 years of back-to-back processing tomatoes in a no-till production system under triticale and vetch and rye and vetch, and he saw approximately 8% increases in soil carbon in the top 6 inches after 2 years of no-till. One of the most surprising things I think about that West Side San Joaquin Valley study was these data here, in which the number of earthworms, there are very few earthworms in western Fresno County annual cropping systems, but after, again, 2 years of back-to-back no-till cover crop systems, he saw significantly higher earthworm populations. We then were, based on those early preliminary findings, got a number of inquiries and interest on an on-farm context. So what you can see here is a number of different permutations on this basic cover crop mulch system compared at 2 sites in Tracy and then Vernalis with a standard conventional system. And what you can see there, I think, is just in general the capability to maintain yields under those mulch systems. And the interest has grown in a variety of popular outlets, and there have been a number of reports that I presume a lot of you have been keeping track of. Now, one thing that we didn't have in place here, and we hope to have the focus of next year's conference surrounded around the SAFS project, which is now entering the conservation tillage arena. Well, but down in 5 Points, we have a comparison of tomatoes, cotton, or cotton, tomatoes, a 4-year study, both of those sequences, with standard tillage with the cover crop, standard tillage without a cover crop, and then a reduced tillage program for tomatoes and cotton with and without cover crops. And what we've got is some very interesting preliminary results here. These are the yields of tomatoes, processing tomatoes, tons per acre, under our cover crop systems and our non-cover crop systems with the 2 tillage treatments imposed here. And what you can see is in both of the cover crop systems, in year number 1, there was a reduction in yield. That's probably statistically significant there. However, the yields for all systems were quite respectable, over about 50 tons per acre. I think one of the most intriguing things that the tour of participants saw at the 5 Point site on Tuesday was, if you just look at those 4 treatments this year, the processing tomatoes that are following last year's cotton, there were virtually no perceptible differences in canopy vigor and growth this year at all. So that's perhaps encouraging. Now, Bob talked a little bit about the issues that are specific to cotton management down in the San Joaquin Valley. In order to be compliant with the pink bollworm requirements, you have to go in and shred and mix the cotton stalks so there's no green growing material that provides a host over winter. We used one of the implements we showed down in 5 Points on Tuesday. This is called a shredder bedder. What it does is it has some cutting wheels up in this part of the machine that will shred. It'll wind on the cotton plant and shred it all in one pass. It undercuts with a cutting blade down here, and it spits it all out. So you're seeing this kind of a texture on the top. And as Bob pointed out, there are issues that are Ag Commissioner specific somewhat to getting that kind of a condition passed. However, we were successful in inviting the Ag Commissioner out, and this kind of a residue on the surface was passable. I was then convinced by my colleagues down there that, Jeff, you're never going to get water down those furrows unless you clean them out. So immediately after we ran the shredder bedder 1 pass post-cotton harvest operation, we pulled the Buffalo with the modified, just shovels there, coulter blades and sweeps behind it to clean the furrows out so that we could have a better furrow irrigation system and that's all that was done before this year's tomatoes. And I wish you had been able to see that. So this is the kind of texture we're doing. Again, when I talked about, you know, the paradigm is going to be different for conservation tillage in California, this might be a requirement or some permutation of this for what we're doing. We then had to look at what we did in the cotton system. We actually made a mistake. We let the winter weeds in the conservation tillage. This is tomato vine residue for the most part in here, and these are some tall weeds that got out of control in early March. We didn't spray soon enough, but nonetheless, we didn't, once they were sprayed with Roundup, we didn't go in and flail mow them. We just planted directly into that residue with the John Deere 1730 no-till planter there, so we were successful with that. Another dimension that really hasn't gotten a lot of information today, but we, with a master's student, have documented the dust emissions for every single operation of all those 4 systems in tomatoes and cotton over a year-and-a-half period. These are shown here. These are pumps that collect the dust, and we pre-weigh dry filters, and then we weigh them at the end of the dust collection effort. And Julie Baker, is also monitoring the composition of that dust. Now, one of the other dimensions that I think is going to be important for all of us who are interested in preserving permanent kind of bed configurations is there going to be consolidation or compaction of those beds that are not reconditioned, refurbished, or fluffed up during the normal tillage operations. And just to show you, after the first year, these are tomato beds, 60-inch tomato beds. There looks like there are definitely differences in the dimensions of those beds that may need to be taken into account in some fashion. Now, we've also done this in single crop studies, single year studies with the different crops. This is showing melons here, and as Max was talking about, this is the uncosmetic or the trashy look on melons. This was strip tilled. We grew an off-season rye, triticale, and vetch cover crop, strip tilled a line in here, put drip right in that line, and then direct seeded melons into the line. And you can see for 2 preliminary small plot year studies, again, there was no herbicide used to kill those cover crops. They were chopped down at a point where they were mature enough, but you still see stragglers growing up there. But at the end of the melon season, you couldn't see those rye plants at all. And again, not analyzed statistically yet, but these are yields that are quite comparable to the standard system here. Now, we've also very recently tried to integrate some of the pest interactions with this, with Charlie Summers and Jim Stapleton, an entomologist and pathologist. They have done years of work with this plastic, silver plastic system here, which for a lot of late summer planted vegetables is very effective in repelling aphids and decreasing aphid-vectored viruses. We tried to compare that with the cover crop surface mulch treatment here and with the standard bare ground system here. And this is for tomatoes. And what we found, first of all, is the tomato growth. This is whole plant biomass here. Plants grow bigger, they grow faster over the silver reflective mulches, and the cover crop plant growth actually lags a little bit behind even the standard tillage. However, at yield time, in our early season tomato work, we were getting yields over the cover crop mulch that were comparable to the non-cover crop mulch, but again, quite behind the silver plastic mulch. It's not going to work in every case whatsoever. Mill talked about the use of sorghum Sudan. We have had rather dismal experiences with sorghum Sudan cover crop. This is tomato biomass again throughout a late season cover crop with sorghum Sudan. We got absolutely no growth in tomatoes at all. In fact, it was an utter nightmare, and I'll share some of our failures here. This is sorghum Sudan regrowing in a tomato season, and you see no tomatoes in there whatsoever. So there may be allelopathy. We've since researched that, and it looks like it's a fairly convincing case that sorghum Sudan might not be a suitable candidate as a surface mulch condition, cover crop here. We've also more recently, with Charlie Summers and Jim Stapleton, looked at the same 3 treatments, cover crop, bare, and silver, and with squash, again, late summer planted squash, it's prone to aphids, and some very intriguing and interesting results in terms of the cover crop mulch able to repel some of those insect pests as well. Now, you have seen and heard through the farmer comments this afternoon that there is a lot going on. Truly, that's a fair statement, I think, at this point, and it's been documented by our work group. One of the farmers here locally, Tony Turkovich, a couple years ago asked Gene Meow and me to come out and bring our transplanter. And this is somebody who has already got in mind the idea of maintaining surface residue and seeing what is going to be possible in that residue. Can you get a crop into that kind of a residue? something you didn't see here, but farmers down south, and Bruce is doing this here, taking 60-inch wheat beds, and as soon as that wheat is harvested, go in with a second crop of corn right on top of those 60-inch beds with a no-till planter in this case here. Another farmer down there has actually set up with us a replicated 3 replicates of 7 different cropping systems. Here you can see him, Bob Price, the farmer down in Riverdale, using a buffalo ridge-till planter to plant cotton into a barley cover crop. So there is, without any question, a lot of work that's going on here. This is John Diener, a farmer in the Five Points area, with last year's corn residue, ridge-tilled, planted cotton into this year. Now, let me end up with a couple observations that are going to be trouble spots for this whole system. A lot of you who are involved with the processing tomato growing or industry recognize these slides here, where you've got the processing tomato trailers that are coming through the field with their double or dual tires here, with 26 tons of tomatoes in those trailers. That's going to be something that's going to be needed to be addressed at some fashion. And I just learned yesterday, in 5 Points on Tuesday, that there are now individual farmers and also companies that are beginning the work toward alternatives in terms of some of the kind of tire configurations that people are doing. So I think that's going to be very interesting to see here. Okay, what are some of the issues that in my experience, I guess personally and as the chair of the work group with the university, have seen as a benefit of being involved with a lot of these projects? One thing I think it's fair to recognize is that you can't underestimate the management changes that are going to be necessary. You've heard that, and I don't mean to make this, overstate this, but some of these things are going to be requiring maybe not any more complex management, but a lot more foresight and insight into what some of the issues are going to be needed to be negotiated in the future. I really think, and this is something that's more relevant down south, but it may be time under these conditions to reconsider some of these cotton stalk management prescriptions that are currently required by law. And there may be some options, or maybe that's something that it cannot be changed. I'm not sure about that, but I think we need to reconsider that. I think, as I mentioned about the tomato harvester, there needs to be a very, very concerted effort, if it's economical and if it makes sense, for these systems to invest in zone traffic harvest equipment. That's something that is clearly going to be needed if they're going to be successful crop to crop. Problem solving IPM, obviously, problem solving in the sense that if there are problems recognized, we need to go to those next steps to overcome those problems, and not just necessarily say that the systems are going to fail. And finally, I think, as you've heard from other speakers as well, we've really got to, and I think we are, thinking of the entire system, the off-season and the crop that's growing currently as well. And with that, I'll stop with the last couple of slides here. A lot of the themes that we've heard in these last 2 conferences that we had last year with the farmers from other places, these are some persistent themes, I think, that really these systems, in order to make them work, are going to take extra management perhaps and a lot of innovation on the part of growers and researchers. They're going to take persistence. This is not going to happen automatically or simply in a lot of cases. I think a maxim we might consider here is adapting and not necessarily adopting wholesale what we've heard from a variety of sources today. It's going to take some refinement, and also think systems. And with that, I think I'll end by thanking you all for taking part today. I hope it was useful, and have a good trip home. Thanks very much.